Good Tuesday to you, everybody, in Gov 603. Welcome to week Kaboom 4. How you doing? How's everybody doing? You hanging in there? Ooh, let's get this started right. Delicious. All right, that's better now. I am your sufficiently caffeinated instructor. And yes, there was a t-shirt. This is not a drill. We are live. All right, let's talk about what we're reading this week for week 4. As always, when you start the week, if you go to the module and look in overview, that'll give you the big picture, and then you go. I mean, I think in Canvas, once you read a module, you can go next. Then scroll over to study, and that will tell you what it is you need to read. There are some articles attached to this week, right? So read Powner, chapter 3, and then a couple of articles I think, well, at least one I think you're going to enjoy, maybe a little unusual. It is, why did Van Gogh cut his ear off, or cut off his ear, I suppose. The problem of alternative explanations in psychobibliography. That is, writing about why people do things who are no longer here and we can't ask them. And then an article on a unified theory of causality. And then a brief reading on describing relationships and causal diagrams. And if you're not getting the theme for this week, the theme is all about the difference between correlation and causality and how we determine the two. And this is fundamentally important for empirical research. And within the sphere of political science, it is not only fundamentally important, but when applied to the field of politics, let's say, now this isn't the only place that, you find the work for political science applicable, but let's say that you're working with a candidate or an elected official. Okay, you're working on a campaign, or you're working with a group that is in support of someone who's already elected. Okay, your ability to determine whether a proposed policy by that candidate that is in the context of elections, or actual proposed legislation in the context of elected official, your ability to determine whether the issuing of that is, hey, this is what we're going to do if I'm elected, or this is what we're going to do concerning issue XYZ, your ability to determine what happens, that is how the public reacts, to determine whether the public was reacting that way because of something else and it had nothing to do with the issued policy, or the issuance of the policy or the legislation or whatever caused their reaction. All right, that's the difference between correlation and causation. So here's a maxim, right? A statement, a saying that I want you to commit to memory. Okay, correlation is not causation. One more time. Correlation is not causation. And what that means is, just because two things happen at the same time doesn't mean that the one thing causes the other. And in life, not just in politics, this is where most people run afoul of trying to make decisions about what to do based on what's going on around them, what's happening. They confuse correlation and causation. In fact, I would argue more often than not. And as political scientists and as communication scholars, if you can imagine in terms of the discipline, this being like an office, we share office space with people that do anthropology, with people that do sociology, with people that do psychology. That is, our desks are sort of right next to each other. We're doing similar things. Now, the difference between, say, someone in political science or someone in communication or someone in, say, psychology is that in political science and in communication, You can, you will, you know, what you want to do is get to the level in which you can diagnose someone's behavior, or someone's, a big group. You can say, "Hmm, I see what's going on, and this is why they're doing that." And that's what a psychologist does. The big break, the difference between political science, sociology, communication, and psychology is we don't have any clinical training, and it's really not our job to tell the individual, well, this is how you stop doing that, or this is how you do more of that. That's what a psychologist would do, would sit down with a person and say, you know, I can diagnose what's going on, and now this is the appropriate course of action. That's not something that we do. We don't do the clinical part. We don't do the diagnostic part, or we do the diagnostic part, not the clinical part. So within that area, that sphere, the diagnostic part, it is essential that you learn the tools, and in this case, as it pertains to empirical research, that allow you to distinguish between correlation and causation. Okay, so commit that to memory. Correlation is not causation. And what do we mean by that when we say correlation is not causation? Well, first and foremost, we mean fundamentally that just because two things happen at the same time doesn't mean that the one thing causes the other. So, for instance, you could just collect data, you know, descriptive statistics, statistics that describe the number of things. And you could collect data on the sale of ice cream and the number of drownings in swimming pools, say for a large city like Los Angeles. All right. And you would find, just by counting and looking at the two numbers, that as the sale of ice cream goes up, the number of drownings in pools go up. But does that mean that people that eat ice cream are more likely to drown? No. What it means is that in the summertime, see, there's another factor in here that you know is not being taken account for. In the summertime, as it gets hotter, people buy more ice cream. In the summertime, as it gets hotter, more people spend time in pools. And as more people spend time in pools, the number of people who drowned in pools go up. There is a correlation, but there is not a causation. Okay? That's what it means. Causation means the one thing is actually causing the other. Now, it's interesting. I used the ice cream in the pool example on purpose because for a long time, it was assumed that if you ate, you should wait at least an hour or two before you go swimming, because there was a assumption based on correlation that eating before going swimming made it more likely that you were going to drown. And there was all kinds of explanations, you know, put forward for why that was. Well, you know, it causes your muscles to cramp as blood enters your digestive tract and moves away from your muscles, or it causes a sense of fullness that makes it hard to focus on your swimming, because you know after you eat you get drowsy, you get full. None of it's true. Okay, eating before swimming does not make it more likely that you're going to drown. That was a false conclusion based on corollary data. Now, the interesting, you know, part of that story would be, where did it come from? Were they looking at sort of? I suspect, I don't know, but I suspect it's like the ice cream analogy, that people were looking at the number of people that went to picnics and had fast food and, you know, grabbed a hot dog or something, and then jumped in a pool, and then drowning going up. And what I would bet, again, I don't know, this is my speculation about the correlation. What I would bet is it's exactly the ice cream analogy, that as the summer months went up and people started eating outside and eating around swimming pools and having picnics and then going swimming, whether it was in a pool or a pond or whatever, that number went up with the summertime, and then the number of people in the water goes up, which means the potential for drowning or near drowning goes up. And they were like, aha! And it was a correlation. It was not a causation. Okay. Causation is when one event causes another. Now, when we say event, and we talked about this terminology in week 3. So in my other video, I'll get to that. We mean anything. This could mean what someone does, what the environment does, what someone thinks, some natural event. A variable is any event. And when we say event, it doesn't mean like like say me, if I drop my pen, which I wouldn't because this is my favorite pen, that would be an event. Or if I'm sitting here thinking about what I'm going to have for dinner, that's an event. All right. A variable is any occurrence, anything that happens. So the independent variable, right, is the thing that's happening. And you could, it doesn't mean that it completely happens on its own and it's not connected to anything. In fact, all actions are all connected in a long chain to each other. It's all causation. But anyway, the independent variable is the thing that happens, and then the dependent variable is the thing that gets caused. So in causal relationships and in causal calculations, as we're trying to figure out if this causes this, we say the standard American term is independent variable. That's the thing that happens. Dependent variable, that's the thing that gets caused. Okay. All right. So for this week, the readings the readings in the textbook and the supplemental readings are all about getting it into your heads, the difference between correlation and causation. And then as we move ahead in the course, you're going to learn how to calculate, and I mean calculate using some some statistical engines. You won't have to do the math longhand. You're going to be able to calculate causation. Now, excuse me, except in rare instances, causation is rarely one-to-one. That is, that this happens and then this absolutely happens in the same measure to the same degree as this thing happening. All right. Because there is rarely a single cause for an event. All right. So what happens in causal calculations is you're going to get a number it's not a percentage in the sense of, how much of a dollar do you have, but it's a number that will tell you, how likely it is that this thing caused the other thing. All right. And I say dollar, I was just thinking, I just looking down, I saw a dollar. So, because it's not like, 50% of a dollar or 75% of a dollar, something like that. All right. So you'll get to learn how to use a stats engine. It's an online site where you plug in some numbers, and then out the other end will come a number that will give you a low, medium, high causal relationship. And you can look at that number and go, yeah, there's a high probability that this thing is causing this thing, or it's a low probability that this thing is causing this thing because there's no causation at all. It's just correlation. It just looks that way. And one isn't causing the other. Okay, so that's the focus for this week. As you go through the readings and focus on the questions, remember to keep working on your papers. If you have questions about those, that is, what am I doing? And how do I do this? Please contact me. And remember, keep in mind that what you're doing with your papers is this is a research proposal. All right. So imagine that you're trying to get money for a project. So you have to describe all aspects of the project, how you would go about gathering your data. Are you going to use a questionnaire? Then in that case, you have to supply the survey. Okay. What are you going to do with it? What are you trying to establish by way of causation? The best way to approach this, if you're unsure, is start with a hypothesis. And remember, this is back from a couple of weeks. A hypothesis has 3 parts. Okay. Number 1, it has at least 2 variables because a hypothesis tries to demonstrate causation. Now, let me just say, a hypothesis is different from a research question in that a research question just asks an open-ended question. There's no attempt to establish causation or to test causation is the term that we use. So a research question would be, does eating an hour before swimming make it more likely that someone will drown? That's a research question. All right. A hypothesis has two variables, makes a prediction about causation, the effect of one variable on another, and has a direction. So what do I mean by that? Well, let's go to the food and the swimming analogy. So a research question would be, does eating an hour before swimming raise the likelihood of drowning? Question. Well, we don't know. Here would be the hypothesis. Eating an hour before swimming is positively correlated to an increased risk of drowning or a higher rate of drowning. All right. So what are we saying in those three things? Here's our two variables, eating and drowning. So that's the first part of our hypothesis. Secondly, here's our causation. All right. The eating, the more that someone, not the more they ate, but if they ate an hour before, the more that happens, the more likely it is that they're going to drown. That's a causation. And then a direction. Eating leads to trouble with swimming, not trouble with swimming leads to eating. It doesn't, we're not talking about it going in the other way. Maybe someone has a near drowning incident, and the first thing they do when they come out of the pools, they go, oh, pass me the potato salad. Probably not. But anyway, you get the point. We're making a prediction about a direction. Those are the three elements that a hypothesis needs. So it's often helpful when you're trying to design a research project, start with a hypothesis, construct a statement that contains those three elements, at least two variables, with a prediction. And this is the important part, with a prediction about the causal relationship of the one to the other, and then a direction. And be as specific as possible. All right. So notice we didn't say drowning in swimming pools, drowning in ponds, drowning when the water is, 70 degrees as opposed to 80 degrees. And 70 would feel cold if you jumped into a pool at 70 degrees. And then you notice we didn't say eating hot dogs as opposed to eating hamburgers, or eating potato salad as opposed to, eating, I don't know what, think of picnic food, fruit, whatever. Okay. Now, if you wanted to talk about, all the things that go on at a picnic, and you were testing this hypothesis, then you could even get specific and say eating hot dogs 1 hour before swimming in a public pool is positively related to an increase in the rate of drowning, right? So you can break a large study into several hypotheses. That's okay. You can have more than one. All right. But for your purposes, for your paper, one or two will do. So think of a hypothesis that has two variables, has a causal relationship between the variables, that makes a prediction, and that prediction has a direction. And then start writing your paper. So think, okay, if I had money and time to research an issue that was related to the larger political sphere, because you're not researching like the weather on amusement park attendance, right? This is a poli-sci class. Okay, what interests you? See, this is the beauty about what you're doing right now. You may be running your butt off and thinking, tell me where the fun is here, Dr. Gardner. Well, I'm telling you, the privilege is you get to work on anything that you choose, which is a rarity in the work world. So although you're busy, you're probably you're working and you're going to school, and some of you even are trying to raise families. I get it. I did it. Treasure the opportunity, the blessing to be able to work on anything that floats your boat. All right. Don't let that pass you by. So start with a hypothesis. And then from there, you will build your introduction saying, well, this is something that's been going on, say the relationship between how late the polling centers stay open, and an impact on voting, especially among the elderly who can't stand in line as long, or the working People have to, or the people below poverty line who have to work 2 jobs because they can't get off a second shift to get there. All right. So you can start the introduction, say, this is what we're going to look at. This is why this is worth your time as a reader. And then for your literature review or your annotated bibliography, what have other people done by way of studying the causal relationship between voting centers, polling centers staying open, and the impact on votes among the elderly and the working poor? Has anybody else researched that? What do they say? You're listing that in your annotated bibliography. And then in your methodology, you're saying, well, this is how I'm going to go about gathering the data and then analyzing it. I'm going to go around and I'm going to first record the times that polling centers, voting centers stay open. We're gonna record that time. And then I'm going to, because when people vote, they don't give your age or your income. That's illegal. I'm going to ask people who are above a certain age. Let's just pick a number. Let's say 65. Who are above 65? Did you get out to vote? And I'm going to ask people, a whole bunch of people, how much money do you make as part of my survey? And those that fall below the poverty line, the federal poverty line, I'm going to ask everybody, how much money do you make? I'm going to ask, did you get out to vote? And then I'm going to look at those who fell below the poverty line to see if they said yes or no. And then I'm going to take that variable, and I'm going to take the variable of when the polling place closed, and I'm going to run a causal analysis. This is you describing this in your methodology section. All right. Now, the nice thing about this paper is you don't have to do this. You don't have to go out and collect data on when polling places closed, and you don't have to actually run the survey and ask people, a broad base of people, what's your age, what's your income, did you get out to vote? You just have to design it as if you were going to do it. Okay? So if you keep working on your papers, if that explanation for part 1 still leaves you with some questions, reach out to me. Call me during my office hour. I'm here waiting for you. All right, because I'm here for your professional development. Okay, everybody, have a fantastic week. This one ran a little longer than I wanted, but enjoy week 4, and I will post the second video in which we review the discussions from week 3. Take care. Bye-bye.